This lesson is going to examine how we could look at polynomials and division of polynomials and determine their remainder. Because as the statement says, in math it's sometimes important to know the value of this remainder, and sometimes we just don't want to divide, either being through long division or synthetic division, to find the remainder. So we have what we call the remainder theorem. Now it's a really easy concept. We're going to look at it through a few examples, and then we'll build on it with the factor theorem in the next video. But the remainder theorem is simply this. If we're dividing a polynomial p, so the polynomial's name is p, by a factor x minus r, the remainder is equal to the value of the polynomial if we evaluate it at p at r. Now that looks confusing. That's a math technical sort of way to talk about this, but we're going to look at it on the next page here on how exactly we use it. So these questions here are saying, what is the remainder? So we have a few of these examples, and it's just basically saying, if I take like example A, if I take this quadratic, x squared plus 5x minus 24, and I divide it by x minus 1, what am I left with? What's the remainder? So you can do this through synthetic division. You can do it through long division, but sometimes we just want to know really quickly what the remainder is. So here is the whole x minus r part that we said in the remainder theorem. So really, if I was to think of this as a factor or something I'm dividing out, we could say, well, x minus 1, that relates into x being positive 1 if I solved for x, making x equal to 0. So we add the 1 to both sides. So all this says is take this polynomial here and evaluate this thing when x equals 1. So we're going to say take the polynomial and put in a 1. So that's basically 1 squared plus 5 times 1 minus 24. Now we should be able to do this in our head, or you can go to your calculator and figure it out. But basically what this is telling me, if I was to crunch this out, I would have a value of negative 18. So the remainder, if I was to divide these, would equal negative 18. So a statement I could write is that the remainder, when we divide those, equals negative 18. So that's a lot quicker than actually doing the division. So we can look at the next example and see how we can do this as well. So we're saying we have x squared plus 5x minus 2, that's our polynomial p, and we're dividing it by x plus 2. Well, from here, we could determine negative 2, solve for x if x plus 2 equals 0. So I'm going to put into this polynomial a negative 2. Now this is where brackets, back to your early stages with substituting in an algebraic expression, becomes important, because the x is squared, sir, so I need to have negative 2 squared, not just a negative 2 without the brackets. And then 5 times negative 2 minus 2. So if I evaluated this polynomial at negative 2 and did all that work either in your calculator or by crunching out the numbers in your head, we get negative 8. So what we do know now is that if I was to actually do this division through long division or synthetic division, I'd be left with a remainder of negative 8. The last one here probably takes it a little bit of a challenge for us, where it's saying x squared plus 5x minus 2, that's my polynomial, and I want to divide it by 2x plus 1. Now, this is a little bit different in the sense that here's my divisor. I'm dividing this out, so I want to set this equal to 0 and solve for x. So back to our early days of algebra, we should get x equaling negative 1/2. So this is what we're going to put in to our polynomial to determine our remainder. So we're going to say if I evaluated the polynomial at negative 1/2, what would my remainder be? So again, it's a negative. The brackets are going to play a huge role here. So negative 1/2 squared plus 5 times a negative half minus a 2. And again, how you go about getting that, probably the most efficient and what you would like to do is your calculator. You might be able to do it in your head as well. But if you do this out, you're either going to get negative 4 1/4, or if it was written as a fraction, that's negative 17/4. So this is the same answer both ways. So the remainder here, if I was to actually take that and divide it out I would have a remainder equal to negative 17 over 4. And that's basically a very, very quick way to determine what the remainder is without actually doing the division. So we're going to use this now to solve a little bit more complex situations here. And here's the challenge. And sometimes these make good numeric response questions on a diploma exam. And this one's saying, when we have the polynomial x cubed plus 3x squared plus cx plus 10, and we divide it by x minus 2, we know the remainder is 6. And it's saying, what's this value of c? So this now is a situation where we have an unknown in the original part, and we know we're dividing it by x minus 2. So from this x minus 2, the remainder theorem says, well, if I was to evaluate the polynomial at 2, I should know that the polynomial when evaluated at 2 equals 6. That's what the remainder here is saying. So all that means is if I take that big thing, I'm going to rewrite it since I'm moving down some steps here. If I had the x cubed plus 3x squared plus cx plus 10, and I was to put a 2 into this polynomial, evaluate the polynomial at 2, so 2 cubed plus 3 times 2 squared plus c times 2 plus 10. If I was to put that in, the remainder theorem says that I should equal 6. So now you could see in this statement or this equation I wrote, I only have one unknown, which is c. So I can go through and evaluate. So 2 cubed is 8. And we could say 3 times 4, that's 2 squared, that's 12. C times 2 is 2c. That would be plus 10 equals 6. We can group all the constants on the left side of the equal sign. So 8 plus 12 is 20, plus 10, that gets me 30, plus 2c is 6. And now this comes down to a simple junior high type sort of question where we're just going to take 30 away from both sides to solve for c. So I'm getting 2c now equals negative 24. The last step is to divide out that 2, and that gets me c being negative 12. So in this situation, I used my idea of the remainder theorem because it told me if I divided by x minus 2, I'm going to get a remainder of 6. So I put that information in. So from x minus 2, I've got this 2 that I could plug into here. And it also told me the remainder would equal 6. So I made that equation. And then I simply just continued through and solved for c. One last type of question that's going one step a little bit further. It's saying, when I take this polynomial, negative 2x cubed plus cx squared minus 5x plus 2, and I divide it by x minus 2, or I divide it by x plus 1, I get the same remainder. And now it's saying, what's the value of c? So this one's taking it a little bit further in the sense that it's saying, I can divide it either by this divisor or this divisor, and that means my remainder is the same. So really, we should be able to tell that x minus 2 from the remainder theorem, I can put a 2 in to determine my remainder. And from this other factor, x plus 1, I could put a negative 1 in to determine my remainder. So it's saying if I take the polynomial and evaluate it at 2, I get the same thing as if the polynomial is evaluated at negative 1. Both of these would give me the exact same remainder. So these evaluations would be the same. So now I can go in, it's a little bit bigger of a question, and I could substitute in on this side, negative 2 times 2 cubed plus c times 2 squared minus 5 times 2 plus 2. That's evaluating this big polynomial up here at 2. And then it says that would equal the same thing if I took that same polynomial and put in a negative 1. So negative 1 cubed plus c times negative 1 squared minus 5 times negative 1 plus 2. So now really, I have a pretty simple question. I just need to find and solve for C. So we go through and we do some number crunching. Here, this is -2 times 8 plus this gets me 4C. This gets me a -10 and a 2. Over here, a -1 cubed is still -1. So -1 times a -2 is a +2. Here, -1 squared is a +1. So that gets me a +1C. These two negatives make a positive. And I'm left with 2. We just clean house by doing some constants and cleaning things up. So we get -24 plus 4C on this side. And over here I get 9 plus C. So now we're left where things are looking a little cleaner. And we have C's on one side, C's on the other. From this step, you just got to move all your variables to one side and your numbers to the other. So I would probably say, you know what, I'm going to take this C and move it over here because I have more C's on that side. So that gets me -4 plus 3C, or sorry, -24 plus 3C equals 9. Add the 24 to both sides to get rid of it on the left. So 3C is 33. Divide out the 3, and now we get, in this question, C is 11. So all that's telling me is back in that original question, I'm going to scroll back up, that if this C right here was well, I can't remember what the answer was an 11. If the C was an 11, if I divided it by x minus 2 or x plus 1, I'd get the exact same remainder. So that's using the remainder theorem, just basically taking a value from the divisor, evaluating the original polynomial at it, and we could then determine what our remainder is without actually having to divide.